Okay, so today we're going to be talking about the shapes of data displays. We did learn about this last year, but it's good to review. So basically, there's three different types of ways that data can be shaped. It could be symmetric, skewed right, or skewed left. So if we look at this first histogram here, this is symmetric because if you draw like a curve like this over the data, it makes a bell shape, and that means that the data is evenly distributed about the center, okay? When this happens, the mean and the median are the same, or about the same. They're really, really close, okay? So it's balanced on the right and the left tails. This is what it would look like in a box plot. You have your box like right in the center of the whiskers, okay? That's what it would look like on a box plot. So the mean and the median are about the same, okay? Now, if we look at this data is skewed right, because if we drew a curve above the data, we would notice that there's a tail here, okay? So we have a tail on the right side. So since the tail is on the right side, that means that it's skewed right. Same thing if we look at this box plot. The tail, we have like a long whisker on the right side. So it's skewed right, okay? When it's skewed right, that means that the mean is going to be greater than the median. The reason why that is because the median is the center of the data, right? You would list all of your values from least to greatest, you'd cross off, cross off, cross off. The median is the center. But what happens is, if it's skewed right, that means that there's some outliers over here. There's outliers on the upper end of the data, which are gonna pull the mean up, okay? So basically what would happen is if you took out like let's say if your data was skewed right and you had, let's say, a value all the way over here at 13, but most of your values are at like 2, 3, 4, this is where most of your values are. If you had a value over here at 13, if you took that value out, then it would center your data again, okay? It would bring the mean back down to where it's supposed to be. This could happen like if you maybe give a test or a quiz or something and the whole class is kind of like in the 70-80 range, and then you have one person that got 100 on it. Maybe that one person really understood the content, and then maybe for the rest of the class you need to reteach it. Something like that. Okay, now, if we look at this one, this is skewed left, and that's because if you draw a curve over the data, you're gonna have a tail on the left side, okay? And if you look at the box plot, we have a long whisker on the left side, so this is what it would look like in a box plot. If it's skewed left, that means we have some outliers on the lower end of the data, so the mean and the median aren't gonna be the same. The mean is going to be less than the median, okay? So basically, once again, if you had a value, let's say an outlier down here at like 1, if you took that value out, it would center the data more, it would bring the median back up, okay? So you're gonna do some IXLs today on outliers and talking about what would happen if you remove the outlier. Yeah, that's about it.